among the significantly to the data science community with his articles and research. Today, our session is about mastering deep learning with Keras from zero to hero, and he will take us through incredible deep learning. And Ammar will guide us with the fundamentals of Keras to building the neural networks, and while showing us with the hands-on examples. So, whether you're just getting started or aiming to sharpen your skills, this session will be valuable for you in all the manners. So on to you, Omar.
Thank you so much, Kainat, for that introduction. So, first of all, good morning and Assalamu alaikum to everyone who has joined. First of all, as Kainat already introduced, I am Ammar Jamshed and I am a data consultant at AI DataYard, a startup which is responsible for building data solutions. And we also conduct trainings in data science and business intelligence for all professionals of all backgrounds. and uh, and yes, by the message, the meeting is being recorded. Don't worry, it already is being recorded externally for another app. So first of all, thank you so much everyone for joining. I understand it's a weekend and you guys gave your time to learn something new. Such ideas and such attitudes towards learning and development are what change people's futures in the right direction, or a direction even greater than where you have been. So before I start my session, first, though, I would like to first say that normally, though, even I have a very busy schedule in terms of work and meetings all the time. But since Ali and Kainat approached me, I obviously couldn't say no, because obviously I always love contributing back to the data community in Pakistan. And obviously, wherever I get the chance to guide anybody in terms of how they can improve their career lines, I will always say yes. Okay. And the world of Keras, as we all know, right? Keras is a deep learning library. Initially, it was just built as an API connecting to other, like deep learning frameworks, but now it's a library of its own, integrated with TensorFlow. So everyone, has heard about what deep learning is, right? That it's a more advanced stage of machine learning. In machine learning, to whenever we are uploading data, right, we have to do a lot of data cleaning ourselves. Because remember, end of the day, data analytics and machine learning, they work on garbage in, garbage out, right? But deep learning and especially frameworks like Keras, they do that for us. We legit don't have to do much of the data cleaning because they do everything for us, right? While it makes our work easier, but at the same time, end of the day, everything has a trade-off. Everything has a price. Because they're doing everything for us, it's consuming much more computing power as well. And all of us have limited time on servers, limited time of storage of computing power and bandwidth as well. Imagine the number of hours going into training with deep learning would be much more than what you'd be doing with machine learning. So they'd exponentially increase your cost in terms of server renting and even cloud computing storages and even cloud computing, machine rents. All of that is taken into account whenever we're deciding to make a data solution. So my session today, is just going to be about an introductory view on what Keras is. And obviously, I don't expect everyone to understand this on first go, but they will be getting an idea of how we can use it. Okay. If you already know Python and have worked with machine learning, probably everything I'm going to say is something you probably even know better than me. But if you're new to Python and machine learning, this would be really something, interesting for you to know about. And even those who are experts in machine learning, they might get some ideas from my session, no idea, or maybe I'd get better ideas from them, from their critiques. I am always like happy to learn new things as well. First, so let me start off with my introduction properly. So as I told you, I'm already a data science consultant. I train professionals in these areas. I also have my own published book as well on data and analysis. I call it the incoherences between data and analysis, that how, we are not using data today in this world the way it should be used. And I was ranked as the top 10 data science mentors by Kaggle in July 2023 from 250 mentors in the world, and the first one from Pakistan to be ranked in the top 10 list. And I've published multiple articles on many platforms through Medium, Vidya in India, and multiple platforms like Becoming AI in Europe and whatnot, which are published there. And I won a data science article writing competition as well. I've already been ranked in the top 1% in Kaggle long time back when Kaggle was new. Now, to mashallah, a lot of other children, even much younger than me, are ranked higher than me. And I'm happy to even see this, that people are increasingly coming towards data science and machine learning and are trying to integrate it with their aspects and fields of interest. So, and I'm always happy to come to any a conference regarding analytics, even if universities invite me, because end of the day there are always good learning opportunities for me, both as an attendee and also as a speaker. Because remember, everyone, learning and development is a two-way stream. What you people are learning from me, I'm also learning from you, because end of the day we both have our own interests in terms of how we want to grow further. And remember, no matter how much you achieve, you always want to grow further in life, because there's no limit to growth. And I have my own published courses on data science and analytics. The one that's doing the most well right now is this one, which is on my screen. That's data science with quantum computing, where I tried explaining quantum computing concepts through data science. And there are two more in the pipeline as well regarding people analytics that will be published in Sala in the coming year. And these are the list of clients and organizations I've worked with. And currently with AI DataYard, and I'm publishing courses on Udemy. And I'm also right now creating my own startup called CourseMon. Basically, we are trying to be the first ever platform in Pakistan connecting all IT and data institutions in Pakistan that provide training and help people help professionals draft a journey for learning. That once you learn a particular course or a training, then how you can take your journey further from there. Now let's start with the real thing. What is Keras? Like I told you, it's now an open source deep learning API on top of TensorFlow. It's like a library of its own now. And we legit use it to build models and experiment with deep learning models. Because, deep learning, as we all know, it's computationally expensive, like I just told everyone. But at the same time, when you're trying to build a solution, right? Don't just directly build a solution with deep learning and say this is the best thing in the world. You have to first build a small use case with deep learning using a sample data set. Example, a lot of people working in like some areas of supply chain, they will be like that, sir, let's apply deep learning to our data and maybe we'll get a better result. Even deep learning can also not give you the perfect data result if your data is extremely bad. Because end of the day, whenever you're cooking a dish, right, it's going to be as good as the quality of ingredients you're using. So even for a proper accuracy score in deep learning, your data has to have some level of, distribution as well. That, the salaries are increasing at a particular rate, and that employees at a particular rank are also earning a particular amount, and that products which have good quality are being sold. So even deep learning, when it's iterating through your data set, right, it also has to look through all of this in order to give you a proper prediction. And then Keras, it offers a high-level interface for developing and evaluating neural networks. So a lot of people who here don't know what neural networks are. Remember the way your brain functions, right? Like all of you think that, math and statistics are not applicable in real world. They're applicable everywhere, even what's happening inside your brain. Whenever you're saying कि भाई मुझे ये चाहिए, नहीं यार मुझे ये चाहिए, तुम्हारी brain खुद ही probability देख रही होती है, calculations कर रही होती है अपने अंदर कि शायद मुझे इस चीज से ज्यादा utility मिलेगी, इस चीज से ज्यादा satisfaction मिलेगा. All of this is happening in your brain at all times. And we have basically mapped the entire brain's logic in computational algorithms now. And that's what we call neural networks. Obviously, they're not 100% as perfect as the brain. They're just maximum in real world, a POC version of what the brain is. But it's giving us better results of our data, better than what we've been doing up till now. So if all of you already have started with machine learning, trying to use this for a better project might be a good idea as well. And those who've never entered data science and machine learning or even deep learning before, you can think about exploring this to see how you could, get better predictions on your data, how you can use it to build a better solution as well for your company, for clients. Usually, people are every day asking me that, Ammar bhai, yaar, hum certifications kaun se kare hain? कि हमें जॉब अच्छी मिल जाए, हम कहाँ डीप लर्निंग को भेज दें अपने आप को, हम डीप लर्निंग एआई से पढ़ें, यूडेमी से पढ़ें, कोर्सेरा से पढ़ें. आई ऑलवेज हैव द सेम आंसर इन ऑल ऑफ दिस. जितनी भी सर्टिफिकेशंस तुम कर लोगे, इट्स नॉट गोइंग टू गिव यू द सेम रिजल्ट एज व्हाट अ प्रोजेक्ट विल गिव यू. अगर आप लोग एक प्रोजेक्ट बनाओ ना डीप लर्निंग से या मशीन लर्निंग से कोई सैंपल डेटा सेट पे, और फिर वो आके इंटरव्यू क्लाइंट में दिखाओ, दैट विल गिव यू मच मोर वेटेज. बिकॉज फिर तो आपका रिक्रूटर भी देख लेगा कि भाई इस बंदे को आता है काम करना, हम ये जो उसने ये बनाया, हम इसको अपनी डेटा देके ये बनवा सकते हैं ना. सो दैट गिव्स देम अ मोर reliability about your skill. सर्टिफिकेशंस तो करोड़ों लोग करके आए हुए होते हैं इंटरव्यूज में, बट काम करके सब लोग नहीं आए हुए होते हैं. एंड इफ यू डन ऑल ऑफ दिस विदाउट एनी मॉनेटरी बेनिफिट, देयर लाइक इफ वी गिव यू अ मॉनेटरी बेनिफिट, देन मेबी यू आर गोइंग टू मेक अ सॉल्यूशन 10 times better than this, right? So I always encourage you, find the algorithm, get the code, और code अब सारी open source हो गई है. You just have to edit the code for the data results. That's all you have to do now. So learning Python really helps in all of that. This is just a small Python code, okay, of what a deep learning library. Imagine this, that these are just few lines of code that can build an entire model. Previously, let's say 10 years ago, we would be needing 300 lines of codes to do all of this. But Python has automated most of it for us. And let me just show you an example of that on Google Colab as well. Look, here I've also run that whole model as well. So look, I've just imported all the libraries, and this is also a breast cancer data set already uploaded on the deep learning framework. It's for people who want to play with data sets and play with machine learning. So you people can also like copy my code. I'll share the link with you, but otherwise it's already available on Google in multiple places. You can try using this. So after I import the libraries, I first load the sample data set, right? And here I've equated it to a variable called data. From this variable, I've imported in the x-axis, I've imported all the variables of the data. And in the y-axis, I've imported the target variable. So target variable is the variable I want to predict. And the x variables I've imported I've placed in x from the same file. They're the variables I want to evaluate my target variables against. Okay. In the next stage over here, you can see I'm splitting the training and testing sets. मैं इनको split कर रहा हूँ कि भाई ये, और यहाँ पे मैंने टेस्ट साइज देखो 0.2 रखा हुआ है कि भाई डेटा अगर 100 है उसमें से हर 2 रोज पे टेस्टिंग करो, बाकी 8 रोज पे ट्रेनिंग करो उस मॉडल को सिखाओ इन 8 रोज पे डेटा किस तरह होती है, और इन 2 रोज पे बोलो डेटा पढ़ के कि ये डेटा क्या बता रही है आपको. इट्स द सेम सिनारियो कि आप लोग जिस तरह किताब पढ़ के टेस्ट देने जा रहे होते हैं, मॉडल भी यही कर रही होती है कि डेटा को पहले उसमें से ज्यादा चीजें पढ़ रही है और फिर थोड़ी चीजों पे टेस्ट ले रही है अपने आप को कि ये चीज अगर हमने ये पढ़ा था तो इसके आंसर्स ये होंगे. ठीक है. उसके बाद वी हैव टू, बिकॉज ये मशीन लर्निंग में कभी नहीं करना पड़ता, कभी लाइक इन सिनारियो कभी सिनारियोज में नहीं होता, लेकिन डीप लर्निंग में हर वक्त होता है. यू हैव टू ऑलवेज नॉर्मलाइज द डेटा, बिकॉज कभी डेटा सही डिस्ट्रीब्यूशन में नहीं होती है कि अगर लेट्स से हर साल किसी लोगों की इंक्रीमेंट्स 5% लग रहे हैं तो ये मॉडल को देखना जरूरी होता है ना. बट कभी हो रहा है कि किसी की इंक्रीमेंट 10% लगी है, किसी की इंक्रीमेंट 15% लगी है, तो फिर कभी ये डीप लर्निंग लाइब्रेरीज को सही तरह समझ नहीं आ रहा होता कि यार ये डेटा की डिस्ट्रीब्यूशन क्या है, सबकी कोई एक ट्रेंड में नहीं इंक्रीज हो रही है सैलरीज. तो आपको नॉर्मलाइज करना होता है डेटा को कि इसको सही तरह समझाने के लिए कि भाई हर इंसान की अपनी सैलरी रेंज है, तो सबके अलग अलग इंक्रीमेंट्स लेवल उसके हिसाब से लग रहे हैं. तो यू हैव टू स्टैंडर्डाइज द डेटा फॉर दैट, और स्टैंडर्ड स्केलर इज वन लाइब्रेरी व्हिच डज दैट फॉर यू कि मॉडल इसको समझ ले बेहतर. उसके बाद वी क्रिएट अ सीक्वेंशियल मॉडल. ओके, इट्स द मोस्ट पॉपुलर वन अप टिल नाउ इन डीप लर्निंग. अदरवाइज इफ पीपल हु हैव डन दिस बिफोर कैन करेक्ट मी हियर टू. ओके. And then model.add, we add 3 dense layers over here, and okay, and we put epochs in each of them as well. Okay, in the first layer, look, we have placed the shape of the training data, which is x over here, and we've put the ReLU function that's to activate it. I'm not going to go too much in detail over here. They're all reactivation functions that help us process the data. And in the last one, we've put a sigmoid function. So basically, sigmoid is used whenever we want to classify outputs. If something is yes or no, something is good or bad, we use sigmoids in these situations. Okay, not going to go too much in detail here because it would be going too much into advanced machine learning mathematics or rather statistics, and obviously neither do I or neither do you have the time to listen to that today. Okay, so after that, once we have designed the model layers and put the epochs, then we have to compile the model. Okay, and we use Adam optimizer specifically in these situations. Okay, and then the loss is binary cross entropy whenever we're doing classification ones. It's the most popular one in this regard, and we choose binary whenever there is a 0 or 1 answer, like yes or no. Whenever there's one of 2 outcomes, we use binary cross entropy in these situations. And accuracy, a lot of people, whenever I've asked them what is accuracy, they've never been able to give me the right answer. They say that, hey, accuracy is how good the data is, how correct the data is. Well, and then whenever I was working with HR like teams, right, in terms of building better statistical models for their data prediction, they'd be like, we need to be 100% accurate. I would always reply, there is no such thing as 100% accuracy in any solution. There's always going to be some margin of error because machines can never be 100% accurate. Neither can humans. And humans created machines. Do you think they can be 100% accurate if we can't? Obviously not. Accuracy is that how well it has been, predicted the results based on how well it's been fed the data. Okay, that if the training data was, classified as something wrong, and then in the testing we've also classified, the model has also classified the data as wrong, that means the accuracy is there. It's exactly classifying outputs based on how it's been trained. But if, let's say, the data, it's like example, if there was a row stating that a person is going to default, and in the prediction it's coming that this person is not defaulting, that means that the accuracy is not there, because the testing is different and the training is giving a different answer, right? And batch size we choose in terms of how much data we have, and epochs over here we're setting in terms of how many times we want to reiterate the data in the training part. Okay, these are all nodes over here, connecting points of the data, we call them nodes. Okay, and over here we have epochs. Epochs basically is how many times we want to iterate this data, check it from start to end continuously. We get a better answer. And the validation split, again, we set it as 20%, that if what we predicted is exactly correct or not, based on the training and validation split. We also sometimes do a separate validation split as well in deep learning. Okay, and in the last stage, we are evaluating the model on the test data. Okay, because we're evaluating with X test and Y test. Okay, and we're checking the loss. So loss basically is how much error we've had, and accuracy is how much correctness we've had. Okay, so let's look over here further now. Okay, so take a look. When it started, processing the data, it had a 0.63 accuracy, but towards processing it in each epoch stage, it managed to get the accuracy up to 0.97. That is basically 97%. From 60% to 97%, it got the accuracy after reiterating the data continuously. And then some people will be like, if we make more epochs, we'll get better accuracy. No, it doesn't always work like that. Okay, it starts with how well you have split the data, and what how many hidden nodes you've put, and what metrics have you placed. Okay, and which functions have you placed in the model. The accuracy is based on those multiple factors in deep learning. Okay, but it will always start with how correct your data is. Okay, in terms of standardization and distribution. So that's how the final loss will be measured. So your test accuracy is now 97%, meaning from 100 data points, 97 are correct. This is very good. For classification models, 80% above usually is correct. But again, sometimes the clients will be like, try making it better. But remember, whenever people build data solutions, I tell them, if you're getting a reasonable accuracy at start, just deploy the machine learning solution, because over time it will get better. As it starts feeding data, it's feeding on data continuously. When Netflix started its recommendation engine, it's also deep learning based. Initially, it was giving everyone the wrong recommendations of their movies, their labels. But over the number of years, as it kept feeding more and more data, then it started giving people correct recommendations. Just like humans take time to learn, right? Through different grades and through college, school, university, so do machine learning models take time to learn as well. This entire machine learning building process is just us design and testing it to see if it's applicable or not. Okay. Now, like I told you already, right? In import, we have to first start with importing the library. Okay, let me also put this on the slideshow so people can see it better. Okay, and sequential and dense, they are important functions to build the neural network. Okay, and for creating the data according to the deep learning requirements. Okay, and the number of nodes you put in also define that how many stages you're dividing your data with in order to process it. Okay, before you process it in layers. And the last one, stochastic gradient descent, people are like, oh my God, what is this? Actually, I'll tell you, in reality, it's just a fancy word for normal distribution of data. So basically, you're making your data normally distributed in the machine learning framework, so it can predict it. Because majority of major deep learning and machine learning models are basically created on assumptions that data is being normally distributed. We all know that's all a big lie. Nothing is normally distributed, but this is how majority of statistics works. So in order to predict most of our data, we have to first refine it according to SGD to find the lowest loss function to further use for deployment. And then mean squared error for loss for regression. If you have done basic statistics, you'll know what mean squared error is basically. Remember minusing X from mean and then squaring it and all of that, right? And then getting the final error result. Everyone who's done statistics would know this part. If you have not, then you should look this up. It's not really that tough to know about. Okay. you're just minusing x from the mean, and then that, like, the value from the mean, and then adding them together after squaring them. It's something we've all done in statistics. Now, what now? Everyone's going to ask me, tell us what's in it for us to use a Keras. Is Keras beginners friendly? It is very beginners friendly. Like I showed you, like you only have to write a few lines of code to get your answer, compared to majority of other machine learning frameworks. Okay, prototyping, it's really good for prototyping. Okay, if you all have ideas, that you want to show people, or you want to show companies that are involved in building apps, you can easily build an idea like that with deep learning, and deploy it as an application as well through Flask or Streamlit. I'll actually show you a Streamlit deployment, some of my own Streamlit deployments, to make it a bit easier for you to understand. Yeah. Let me just sign in here. See, so these are all the models in the past that I have deployed with Streamlit. Okay, let's see. Some of them were successful, some weren't successful. So which one is? What should I show you first? Any, mini, mini? No. Okay, I'll just show you not my model, but actually a SQL solution I built for AI DataYard using Streamlit. You can also deploy machine learning models the same way through a usable app. So let it just load. So basically, okay, let's get this app back up. Just 1 minute. And yes, sure, everyone keep the questions coming in. I will answer as soon as I'm done with all of the slides. I will answer all your questions. I promise that part. Just let this thing load. So look, over here, I'm uploading a data file. Okay. So which one should I start? Let's say bakery sales. Like all of you who have used MySQL, you probably can relate to this part, right? Look, it's loading my data right now. It can only take up to 200 MB per file. That's just the limitation it has. But it's good for training new people in SQL who don't have the physical SQL infrastructure on their computers, or are using very old ones, which is very common in our villages. Now, and I used GitHub as a backend storage for this because it was open source and I could secure it if I wanted. Okay, now it's uploaded in GitHub. Now I can name the table. Let's name it Ammar's table. Okay. Now it's being uploaded to SQL's algorithm on Python. There's a library in Python known as SQLite. Some people who have worked with Python will probably already know about this. And those who haven't worked with Python, basically, it's an SQL inbuilt library allowing us to do SQL querying on using Python. Sure. So now watch. Select all columns from the table's name, Ammar's table. Now take a look. Basically it has visualized the data. Otherwise, and there's one more thing I added into my deployment, which is not present in any SQL tool either. And I also made a post about it on LinkedIn. Now watch this. If I import only some, visualizations, like this one, let's say ticket number, select ticket number, comma, quantity from Ammar's table. Okay, now I've selected this. Now watch. Now take a look. It's also automatically visualizing the data I've selected to. So without needing to further do anything, I can just directly see the patterns and trends of my data. So I can study it completely. See, it's automatically visualized the data I've selected without needing to use any other addition tool. This is where the method Streamlit is a library in Python too. You can just directly use it to deploy your machine learning like this. So people can use it like an app if they want. So that way they'll be interested to know that if this something like this can help them or not. If you just show them your Jupyter notebook or your Python code on Visual Studio, they're not going to get convinced because everyone doesn't read code. But if you deploy it like this, like an application or like a website, then they'll be interested that, oh my God, we like your solution. Let us adopt it and integrate it with our servers. Okay. Okay, now let's now, okay, let me just, okay, now, okay, so now I already explained this part. Now, how can we use Keras? Okay, so now from current slide. So look, so Keras can be used for these, like, four very important use cases, which are already being used a lot in the world. Time series forecasting, you can use Keras for that, but you have basic machine learning algorithms that can do the same. So in these situations, people sometimes do make mistakes. If a mini machine learning algorithm can give you, or even Excel can give you the exact accurate results with this data, you don't need to delve into deep learning to use it, because you're wasting more time and using more computing resources then. But for text sentiment analysis, image classification, human language like natural language, even through chatbot languages and all, if you're using deep learning for that, it's a very good case, because this is very dense data, extremely collected at large scale levels. So deep learning becomes the best idea, the best use case for analyzing and predicting trends in these kinds of data. And now to you even have, like AI, like what do we say, like chatbot interfaces made with just deep learning. LLM is one example of that. Like it's based on a lot of deep learning algorithms. So it's giving us more accurate results from all of our queries and prompts than probably previous, like, stale algorithms have given us. And image classification, a lot of open CV detection models are based on deep learning frameworks too, for the same reason. They're more accurate. Now, how should data be handled? Like I told you, normalization and standardization is the most essential component of deep learning, especially Keras, because Keras models, they typically perform better when input is scaled from like features ranging from 0 to 1, others from 0 to 1,000. So normalization, scaling data from 0 to 1. Example, like if there's male and female in a column, you will scale male as 0, female as 1. And standardization, again, to have a mean of 0 and a standard deviation of 1. It's a bit more statistically like significant than normalization, but again, it depends on the kind of columns or features you're using. Columns are also known as features in machine learning languages. Okay. So if you're working with image on sequence data, you need to reshape your data as well, because images are huge. You have to reshape them for machine learning models to understand them by making them a bit shorter. Okay. And you have to crop them with those machine learning with Python codes instead of physically doing that, because physically doing so much, like let's say thousands of images, will be too time constraining. Okay. And you have to avoid overfitting data, feeding data more than necessary. Then it ends up giving unrealistic results. You have to process them in batches. So basically, this is where I will have to over here, even though I know this session was much